Hi everybody. So, making another video. I'd had a question about how do we know the trig functions are the way they are. And so I decided to make a video to try and show that. I'm focused right now on my dog Ava, who is just kind of hanging out with me. Here we go. Say hi, Ava. It's a good dog. Okay, so to do this, we are going to begin by drawing the unit circle, but I'm just going to put the unit circle, in quadrant 1. So we're just working with this part of the unit circle, okay? Unit circle meaning the radius is 1. So this ordered pair right here is 1, 0. This ordered pair is 0, 1. But that really isn't what we need. What we need to realize is that what we're forming here, because this hypotenuse is 1, and we're going to start by calling this angle theta. If this is theta, that's 90 minus theta. And because a tangent line to a circle we know meets at 90 degrees. If this angle is 90 minus theta, then that one is theta. And we can use that same rationale here and here when I extend this dotted line over from that piece and say, well, if that angle is theta, then this angle from here to here is 90 minus theta, and we're dealing with, like, we're bisecting and so forth. So what I've done is I basically said, well, this piece is sine because that piece is sine. This piece is cosine because that piece is cosine. Because the sine of the angle is the opposite over the hypotenuse. And if the opposite over the hypotenuse and the hypotenuse is 1, then that piece is the sine of theta. And cosine is adjacent over hypotenuse. So if that is 1, then that's just the cosine of theta. So I'm going to begin by going and figuring out what this piece is. So I've drawn a triangle that is outside the unit circle that touches at the spot where the radius connects. And what we're going to find is that piece is a tangent. So we're going to take this triangle out, and we're going to set it right here. And then what we're going to do is we're going to take this triangle out. We're going to lift it and rotate it so the theta sits in the same spot as the theta, and it will look like this. Now, be cautious when this happens, because recognize that this spot, this side, is the sine of theta. So it's the one that's connected to the theta. So I have sine of theta, I have the theta, and this is the side y that we were trying to find. Now, using similar triangles, y over 1 is going to be equal to sine over cosine. And we know sine over cosine to be tangent. So that piece is tangent. Now, doing what I did with this section, I'm going to do the same kind of idea here. I know this portion is cosine. There's my theta, and this is my 90 minus theta. And I'm going to try and find the length p. So I'm going to lift this triangle up, and forgive me, I'm going to set it down here. So here's my theta, here's my cosine, here's my p. Sorry, folks. So p is to my reference triangle 1 as cosine is to sine. So my ratio looks like this. P over 1 is cosine over sine. So that segment that we talked about is my cotangent of theta. So this piece is the cotangent. So there's tangent, there's cotangent. Now, I'm going to show you that this segment is the cosecant. Sorry, everybody. To do that, what I'm going to do is I'm going to find this segment. So I'm going to look at this triangle here. I'm going to call this piece X. And so when I lift this triangle up and I lay it down, I'm looking at this triangle. So it's going to be X, it's going to be cosine, I'm going to have theta and 90 minus theta. So This cosine here is this cosine there. All right, so now I'm working with the reference triangle and that triangle. So x is to cosine as cosine is to sine. I will cross multiply and I'll get x equals cosine squared over sine. That's going to be 1 minus sine squared over sine. Cosine squared is 1 minus sine squared. That's a common denominator, so it's going to be 1 over sine, and then the signs over here will be sine squared over sine, and they'll reduce. Well, 1 over sine is cosecant. But that piece is actually the length of x. To get this whole side, I've got to add this piece with this piece. So remember, x is what we just got. That was the cosecant x minus sine of theta. I'm sorry, cosecant theta minus sine of theta. And I'm going to add to that the sine of theta. Well, those two eliminate each other, and so we find out that that whole side is the cosecant of theta. So this length here is our cosecant. All right, going to do the same thing here. So we're going to find out what z is. I'm going to take my triangle, I'm going to lift it, I'm going to tilt it, and I'm going to lay it down here. So I have the side z, I have the sine, I have the theta, and the 90 minus theta. I'm going to go back and work from my reference triangle. So z is to sine as sine is to cosine. Z is to sine as sine is to cosine. Okay, now cross multiply, and so I have z is equal to sine squared over cosine. I'm going to convert that to 1 over cosine squared. That's a common denominator, so it's 1 over cosine minus cosine squared over cosine, but they reduce. 1 over cosine is secant theta, and then the cosine is there. So that is the length of z. To get the total length, I have to take this portion and add cosine to it. Come down to here, secant minus cosine, which is the length of that piece, plus cosine. Well, those just eliminate each other. So we find out that this whole side is the secant of theta. Okay, folks, hopefully that helps.